All right, welcome to your first Python lesson. I'm not sure if I'm going to do every single one of them with a video, but I might if you want them to all be videos. The first one I wanted to do a video for sure just so we can get the environment set up and get your code downloaded. You'll need to update it occasionally or re-download the code occasionally because I don't have all the lessons done yet. But for now, we'll start with the first lesson, which is done. So you might have some of these first steps done. I'm just starting on a fresh Windows 11 install. So the first step will be to get Python installed. Oh, this is how fresh it is. I've got to click through this wonderful thing. Okay. We'll go to python.org. And there are a couple of settings that will make your life easier. That's why I wanted to do a fresh install here. And just in case you don't have it, you can see what settings I use when I install Python. So I always add Python to path. This will make things easier once you start to execute Python or pip commands in a command line or in a terminal. Not going to be super relevant right now, but it'll just make life easier in the future. If you don't have this already set up, let me know and I can either make a short little video on to show you where to add Python to path manually, or I can just come over and help you out. So we'll have use admin privileges and then add Python to path. Click install now. Approve that. And wait while it does its thing. We're going to just sit here silently. I always click this because it's not going to hurt anything. And I think in the past I've run into issues with this. I don't remember off the top of my head what they were, but click that button, click yes, and then you're done with installing Python. Next, we're going to do some nitty-gritty terminal work. So open up your terminal. If you're on Windows 10, when you right-click, it'll say PowerShell. PowerShell is fine. On Windows 11, you right-click and it's terminal. And what we'll want to install is Jupyter Labs. So I just want to make sure I'm installing the right one. I was wrong. We're going to install notebooks. We'll do pip install notebook. And this will pull it from the Python package repository. Let this one do its thing. And while it does its thing, we're going to go to GitHub and pull the code. So this link will be in the description of the video. And I'll let you know whenever I update files on here. Okay, so you have GitHub open. We can go over using Git later. So then instead of coming to this web page and downloading everything manually, you can just do git pull, which is a terminal command, or with some IDEs it has a built-in button, or with most IDEs. I don't think I've used an IDE that doesn't have git commands built in and associated with some kind of UI button. But for now, we'll hit code and download zip. And, oh, shoot. I don't think the video or the recording can see that, but my computer freaked out a little bit. Open up your downloads or wherever you downloaded the Python lessons to. I'm going to move it over to documents just so it's not baking in the downloads folder. Right click, extract all. That should be the same regardless of Windows 10 or 11. Click on extract, and then you've got your Jupyter Notebook files there. So to open them up, what we are going to do to skip a few steps is navigate to this folder. So you can see your current path right here is c/users/your username. And that's usually what it'll be regardless of whether it's PowerShell or a command prompt, or in this case, PowerShell running in a terminal, or the terminal application. So you'll want to do cd and then documents. So if you miss what I did there is I typed do and then I clicked tab and it autofilled documents for me. And then we're going to want to make it to this Python lessons folder. Yours might not have extracted that way, but mine did. So we'll do Python and Python again. And then we'll be there in our lovely Python lessons folder. You can check this with ls. This will show you the files that are within that directory. So you can see lesson 1 has some nice fat length because it's got content in it, and lessons 2 and 3 are completely empty. And then what we'll do from here is we'll type Jupyter Lab. Nope, not Jupyter Lab. We'll type Jupyter Notebook, actually. And this is going to think for a second. It's going to launch your web browser. And from here, this is where we're going to do most of our lessons in coding at the beginning, at least. I'll explain why after I open the lesson file. So once you're on this page, click lesson 1. It'll open it up and you'll see all this lovely, lovely, scary stuff. So we'll come down to the bottom here and I'll show you why we're going to use Jupyter Notebook. First is it lets me mix like standard text and code blocks. And second is it instantly shows you the output of your code. So for example, here we've got our code block. We'll just type like print hello world with an exclamation point. And then to run this, you have to press shift enter. If you just press enter, it's just going to add a new line into your code block. So then you can add more stuff if you wanted to. Some of these up here have multiple lines in the code block. And then you press shift enter and it gives you all the output. So shift enter, hello world. So let's, oh gosh, oh my gosh. I'd like to delete that cell. Oh gosh. Delete cell. Oh, it did delete it. Oh my gosh. What the heck? Okay, now we're good. All right, let's start from the top. So all that we've done so far is installed Python, installed Jupyter Notebook, and launched the notebook, and then opened up the first lesson file. So this is going to go over the basics of Python. So Python syntax, we've got variables, data types, and operators, and then we've got, let's see, those are the two sections I have, and then there's subsections. So we've got variables and then operators down here. So we'll do just a brief little like go over of all this. Change that back. Okay. So Python syntax. Python is a little different with its syntax because it doesn't use, like I state here, curly braces, or some languages will just use parentheses. Python does all of its syntax based off of white space, or at least like its containment for different statements or classes and such. For naming, it uses snake case, and so that is every word lowercase with an underscore in between each word. So here we've got my number, my word, my Boolean, all very creative and well thought out names. And that's just the general rule for Python syntax naming. That applies to file names as well as classes and modules. So if you're ever unsure of like how you should be formatting the name of something, it's always just safe to go with snake case. For comments, Python has two kinds of comments. They've got multi-line comments and then single-line comments. Multi-line comments I typically place at the beginning of a file, just explaining briefly what the file does as a whole, or the task of that file. So I just said the same thing in two different ways, but you understand. And I'll often put like an author tag, like this was written by me, this is what, maybe like what version it is, when it was last edited, and that kind of stuff. Single line comments I'll put ahead of code just to explain what upcoming code is doing. This is not a very good example of what I would usually do. This is just it is an example of what I would do. Below our snake case examples. Look at that. I was smarter when I was writing this. And just let me catch up real quick on what I've got going on here. I think that's really it for at least the syntax. For the white space here, you can see that I have these two lines shifted over a whole tab. And that's just giving possession of these lines to this if statement. So this is where the parentheses and brackets or curly braces stuff comes in. Python doesn't do that. You just need to keep track of your white space, and that will give different lines of code precedence. Precedence? Not president. Not the president. Python is not the president, but precedence, I think. I'm a computer science major. I don't know what English words mean. So you'll see little practices throughout each line so that you can apply what you're doing or what you're reading about. Starts off pretty simple, and then I forget to do little examples, and then I give you problems at the end. But here you can see you've created a multi-line comment below. You have an example here that you can refer to if you get stuck. Same with single line comments. You even have examples right there in that code block. And then I do the if statement here for you, not because I don't believe you can do an if statement on your own. I'm just going from nothing and trying to go from there. So I do the if statement for you. I give it a horrible, horrible case just so it'll always run. And then you can put whatever code you feel like in there. In this case, I would like you to put a print statement, then shift enter, make sure it doesn't give you any errors, and then move on. So here I have the variables, data types, and operators. There are a few of them. I don't think I ever use all of them in my own code personally. Like I don't recall ever using a set in my own code. But a lot of these are pretty self-explanatory. Like an integer, that's just a whole number without any decimal places. A floating point number is a number that does include decimal places or decimal points. Boolean is either true or false. A string is just any, it's like a list of characters. I believe that's how Python handles it. It's a list of characters that are joined together. List, it is a grouping of items, and there's written explanations for all of these. So if I say something and you're like, I don't know what the heck that means, you can either read through this or look it up. Look it up on like W3 or Geeks for Geeks, and it'll have probably a better explanation and code examples. So a list, I actually do want to go into these a little more. And I think I don't explain it here. I explain it in this paragraph here. There's a difference between lists, tuples, dictionaries, and sets. They're all minor differences, but like I was saying, I've never used a set in my own code. That's not because they don't have their place. That's just because it never crosses my mind to use them, or I always need them to be editable, or need to be able to access the items in whatever group type variable that I'm using. So sets, we're jumping down to sets. Sets are immutable, so they can't be changed. And then they also don't have a way to easily access the items in there. So like lists or tuples, you can access, you can access the items using square brackets. So we've got our list here, got our tuple here. That's how we're able to access that or any of the items in there. For dictionaries, it's a little different, but you have ways that you can access the items. Right here with our set, we have to loop through the set to be able to access any of those, which is just, it's not super convenient. But like I was saying, if you have a group of things that are staying the same and you don't need to access individual items, then a set could be a good data choice or a good variable choice. It's a data type. Sorry, data type. For lists, they're mutable. So you can change them, you can add items, you can remove items, and you can access them using the brackets like I was showing you. So I use lists quite a bit in my own code. Let's see, I don't remember if tuples are mutable. Same access. Tuples are groups that are ordered and can include duplicates but are immutable. So tuples are like lists, but you can't change them. You can access them with the brackets, but once it's made, it's made. You can't remove items, you can't add items. And for all of these, except for dictionaries, I believe you can have duplicates. That's a lie. Sets, you can't have duplicates. I am all over the place with these. Holy cow, I should have rehearsed this. Dictionaries, they are mutable. They cannot have duplicates. And they have pretty easy access. So a dictionary it's like a dictionary. It's got a key value pair. So you have a key and then you have a value associated with that key. So down here with our dictionary, we've got 1, 2, 3, and that's just translating to the written out version of that number. And to access it, you just say the variable name dot get and then the key. So this would return the value 2, and you can see that here, dictionary value 2. And I think that's all I have on that. There are, of course, other variables or other data types that you can use. And you can even create your own data types if something that's built in isn't meeting your needs. But that's more advanced. We'll go over that later. Down here we have operators. A lot of these, you'll be familiar with, like the arithmetic operators, plus, minus, multiplication, division. And then these last two are the oddballs. We've got modulo, and then this, oh my gosh, is used for, where did it go? Please hold. Okay, this is modulo, and then this is what's used for like to the power of. So modulo is what you use if you need the remainder of like a division operation. So let's say you don't need the division value, but you need the amount that's left over. So for example, something I used this for recently was determining whether a number was odd or even. So every odd number is going to have a remainder of 1, right? So you take the number mod 2, that gives you either a 0 or a 1. And then I use those in if statements to continue my code. This is just exponentiation. So you take your number, throw that sucker on the back of it, and then put another number, and it'll be to that power of. So if you did 2, this, and then 3, you'd end up with 8. Comparison operators. The big one that you might get confused with at the beginning is the double equals. Usually in really any kind of math that we've been taught, or any kind of, I guess, comparisons, we always say, is it equal to? With most programming language, probably all of them actually. We're going to go with most. I'm not going to make a blanket statement like that because I don't know all of them. You use just a single equal sign for assignment. And since it's being used for assignment, you can't use it for comparison as well. That's going to confuse the computer, the language, the compiler, whatever you're throwing it at. And it's going to be like, oh, you're assigning this value when you should be checking it probably. And most IDEs will yell at you about that and be like, I don't think you're doing the right thing here. So you got to use a double equals for comparison, since a single equals sign is already used for other functions. The exclamation point in the equals is not equal to. It's similar to like if you were to have an equal sign with a slash in it, that's just stating that those two items aren't equal to each other. Less than and greater than, and then less than and equal to and greater than or equal to, they operate just like they sound. It's comparing the value of two items and checking to see whether they're less than or greater than, or if you have an equals to sign on the back side of it, sometimes it could be equal. Logical operators and, or, and not. These are often used to... Oh my goodness, Ava's making noise in the background. No! These are often used for... Come here. You're grounded from this for a second. Drop it, please. These are often used to, like, can... Oh my gosh, why are you finding all of these? All right, take 56. These are often used to, like, bridge Boolean operations. So if you have an operation that equates to true and you need more than just that operation to be true, you can throw an and in there. So say like 5 is less than 6, that's true, and 5 is greater than or equal to 3. So that would require both of those statements to be true to continue beyond that line of code. If you use the or operation, only one of those needs to be true. So you have 5 is less than 6 is true, and then 5 is less than 3 is not true. It'd still run because that first statement is true. Not just negates whatever you're saying. So if we take the first example with 5 is less than 6 and 5 is greater than or equal to 3, you can throw not into there and it'll negate either side. So 5 is less than 6 and not 5 is greater than or equal to 3. You wouldn't typically use static values like that example, but it was just for example. For our assignment operators, I love assignment operators, it's freaking fun. We've got the equal sign, which we've already talked about. Then we've got plus equals, minus equals, times equals, divide equals, mod equals, and to the power of equals. So we'll go down to here and then go yell at my upstairs neighbor for deciding to vacuum right now. And we'll explain this a little bit. So we've got A plus equals B, right? What does that mean? It's pretty cool. And Ava took a squeaky toy, so we're going to hear it in a second. But what it turns into is A equals A plus B. So you're taking your initial value, which is A, and then you're taking A, adding B to it, and reassigning it back to A. So you're changing A. This is, I use this all the time for iterations, or I don't know, if I need to get a different mathematical value. And this applies to all of these with the plus, minus, times, divide. All that really changes is what's here. So super duper useful operation, cuts down on code, makes it more readable. 10 out of 10, do recommend. Identity operators, we kind of dabbled in that a little bit with logical operators. Is just like an English equivalent to saying equals. Then is not is an English equivalent to saying this right here. Membership operators, these will be used for your groups, your group variable types, like your lists, your tuples, maybe sometimes your dictionaries. It's used to check to see if a value is within any of those groups. So if we jump down to here, we've got my list, 1, 2, 3, 4, 5, print 1 in my list. Yeah, it's going to return true because it's in that list. And then print not in 6, not in my list. Sorry, let me come back up. Yep, not in my list. As you can see, it is not in the list, so it's going to print out true. If it was 6 in my list, it's going to say false because that is not in that list. All right, and that is the whole, or just like a quick stumbly rundown of what's in this lesson. Then down here we've got a couple of practice problems. If you want to pause the video or close it now, cool. And then you can come back and check to see what I did, or if you get stuck with your own answers for them, you can come back and see. But real quick, I'll just go through each of these. So we've got create 4 variables total. I don't know why I threw total in there, with 1 of each type. 1 string, 1 int, 1 float, and 1 boolean. So we can go with really, really basic, horrible names like my string, my int, my float, my boolean, or we can be creative. String-ish. 1, 2, 3, string. Int-ish. We'll just follow that trend. 57. Float-ish. 420.69. And boolean-ish equals false. And that would be an acceptable answer. You can press Shift Enter. Even though it's not printing anything, still press Shift Enter so that Jupyter Notebook actually assigns these variables, because you're going to use them throughout the rest of the problems. So I'm going to do the challenge part. Ooh, actually, yeah, I'll do both. So print command, print each of your variables out. If you want a little challenge, print all 4 into one line with space in between. I'll go over all 3 ways that would be acceptable to me. I'm not going to grade you like super harshly. We're just learning how to code in Python together, because I've never written Python code ever in my life. Never, ever. You made this choice. You asked me to do this. I'm just kidding. I've written lots of code. Okay, so we'll do the first one. So we can do not string, print, print. Oh my gosh. So this would be the first acceptable way to do that. It prints them all out on their own lines. The challenge part, so there's 2 ways you can do the challenge. So I think I said concatenation. I don't think I spelled that right. I don't even know if I'm using it right. It sounds like it's right, so I'm going to leave it in there. We'll go with that one first because it's less elegant than using F strings. So print, and I think I wanted a space in between each. Yep, space in between each. It doesn't have to be in order from top to bottom, so string-ish. Int-ish. Hey! Don't bark! I'm just typing, dude. Float-ish and boolean-ish. Ah, scheisse. All right. We run into an issue because I'm a fool. We're going to need to convert all of these into strings. I think it's going to need to be all... Heh. Oh gosh. Let me find out what that command is. That's a challenge even for me. Oh my goodness. Integer to string. Oh, I remember. Yep. Okay, so you gotta do str, and that'll convert your value there, and you have to do it for all of them. Acceptable, number 2. As you can see, what are you on about? Not as elegant, not very pretty. I'm gonna add a new line there, just so we have some spacing. Not great, doesn't look good. Very long, horrible looking line of code. Oh, whoops. For the last acceptable one, it's called an F string, and it's pretty difficult. So you put an F there. We'll do string-ish. Int-ish. Float-ish, and boolean-ish. Boom, look at that. Look at how much nicer that is. Beautiful. All 3 are fine. Do whatever tickles your fancy. And if you're watching this before trying it yourself, then shame on you. All right. Create a new variable that is the result of arithmetic between your int and float variables from problem 1. Print the new variable that has that result. So we'll go with our lovely, lovely, lovely new variable name, result-ish. And we'll do int-ish, and let's go to the power of float-ish, and hopefully that's not too big of a number. And we'll do print result-ish. Overflow, yep, too big. So we're not gonna do that, we're just gonna multiply them. There we go. Beautiful. Create a comparison operation that evaluates true using your float and int variables. We're gonna add to this a little bonus exercise. Bonus. Use and not and or and use and or to implement your Boolean variable. Oops. that's already going to be there when you get to it, but you just watched me edit it in real time. Congratulations. Create a comparison operation that evaluates the true while your float using your float and int variables. So we could do like int-ish. Let's print it out. We'll print this. Int-ish is greater than or equal to, less than or equal to float-ish. And then we can do something like and not Boolean-ish true. So I put not there because it's false, and we want this to evaluate to true. So we need to negate Boolean-ish so that it's true. The and operation is so that both of these need to be true to result in true. What we could have also done if we wanted to use or is removed both of these and done or, and that would also result to true, since this operation here turns out to be true. There are tons of ways we can do it. We could remove that because it's 57 is obviously less than 420.69. Yeah, have fun with that one. Play with it a little bit if you want. All right, declare a dictionary with 3 key value pairs and a list with 4 items. Print one of the items from the dictionary and the first item from the list. This is very important, something that I still occasionally forget. Python and most other languages start at 0 when you start counting, not at 1. We only count starting at 1 because we don't respect 0 in language. But in computer languages, we do respect 0. It has a value and a place in its world. So a dictionary with 3 key value pairs. So something that you'll need to read for sure up here is how to declare each of these, or at least look at the examples, because there's different ways to declare each of them. Since we're doing a list and a dictionary, we'll need to make sure we get our brackets or curly braces right. So our list is going to use brackets. Our dictionary is going to use some curly braces. Dick-dish. Careful with that one. Let's see. What do we want to be in here? Let's have some... Why don't we just put our int, our float, and our boolean, just for kicks. And then we'll create. Oh, wait a second. Gosh, dang it. I was a fool. We're going to make this our list. Listish. Dick-dish. All right. Let's do some like Spanish and English. So we'll do bread. Ham. Beer. Cerveza. Meat. Mert. Meat. Don't know why I decided to capitalize that one. Carne. Oh, I failed on my first one. So you need 4 values in the list and then 3 key value pairs in the dictionary. So for the dictionary, we just need to print one of the items. Doesn't matter which one. So we'll print dick-dish and go .get meat. And then the next one we'll do print, and this one we just need the first item, list-ish, and we gotta be careful and use 0. Press Shift Enter, and we've got our first item, which is int-ish, which is 57, and list-ish 0 is What am I saying? I just did that all very weird. Dickdish.get me it printed out carne. Success on that one. Listish sub-0 is intish. Intish equals 57. That's what we got. So anyways, sorry about the random interruptions during this lesson. Let me know if you have any trouble or run into any issues with getting to this point. And I will have a second lesson out for you soon. Thanks. Bye.